Take your break. Because the diatomic lesson was a bit of a segue to why do molecules form. So covalent bonding occurs between two or more non-metallic, occurs between two or more non-metallic atoms. So let's look at our most simple one, right? Hydrogen to hydrogen. They're both nonmetals. They both want to gain. So rather than one losing, they cut a deal and they share. And that's called a shared pair or a covalent bond, or sometimes it's called a molecular bond, but that's not the best term to use, because there are forces between molecules that are also molecular forces of attraction. That's a whole other story, right? But this explains why water has the formula of H2O, not H3O or H4O. Okay? And here's why. If you look at oxygen, has 6 electrons in its valence shell. What does it want to do, guys? How many? 2. Correct. And if there were free-floating hydrogen atoms, notice the term, atom, ion, and molecule, you always have to be thinking about the particle and asking yourself, is that an atom, an ion, or a molecule? And based on that, what does it want to do? Or what is it going to do? So this oxygen here says, I want to gain 2. Okay? And if I gain 2, then I'll be happy. Right? And this hydrogen here is free floating around because it's in what's called the transition complex, which is a whole other story I can get into later if you like. And there's a free floating hydrogen. I mean, they're all kind of around. Everybody's kind of, it's a bit of a free-for-all chaos state. Okay? Old bonds have been broken. New bonds are about to be formed. Okay? So we take this hydrogen gas, we ignite it with some oxygen, and now we've got free-floating elements, atoms floating around, and they're going to go, we're going to connect up in a better arrangement. Okay? So rather than the oxygens partnering together, they actually connect up with hydrogens. Okay? So the highlighter that I'm doing on the thing is just showing the bond forming, and then finally we get the H2O molecule. Sorry. Okay? So, I could represent this another way. I could take this oxygen atom, and I could take this hydrogen, these two hydrogens, and they're going to fuse together to form the water molecules. Okay? So these atoms are free once we've actually hit the spark. Remember I had to add the fire before the hydrogen would actually ignite? That fire was required to burn, or to actually break the bond between that hydrogen. But remember, we also had an oxygen. And what does oxygen exist as? Who remembers? You just taught it. A molecule of O2, right? So I've got a molecule of O2, and I'm trying to break this molecule into 2 atoms. So let's break that into 2 atoms. It's kind of a multi-step process, right? And I've got, well, then how many hydrogen molecules would I have needed to go into my system in the first place? So like here's before, here's during, here's after. Okay? That explosion is happening because energy is released when we break bonds. Okay? Boom! Well, technically we didn't. Well, we didn't lose anything. we had one molecule of oxygen. Remember, we got kind of a limitless supply there of hydrogen because it's coming from the magnesium chloride or the acid reaction producing hydrogen gas, right? So now we've got this during state, which is kind of an in-between state where old bonds are broken and new bonds are about to be formed. We call this the transition complex. Okay? It's kind of like when you're breaking up with your old girlfriend and meeting somebody new. Who's better? Or boyfriend, depending on how it is. Okay? And I'm not judging either way. Okay? It is what it is. Things happen. Things work out, they don't work out. Okay, it is what it is. So we started off as how many particles of, how many molecules, like that? How many hydrogen molecules did we start off with? 2. Now we actually started off with 2 gazillion. We had as many as we needed. Because remember it was coming up the test tube? Right? So there's constant streaming coming up. Where are we getting our oxygen molecules from? Everywhere. They're all over the air, right? So I'm only zooming in on one little system, not the whole thing. Okay? But we add a spark. I don't know what happened. There's just this spark that I felt. Okay, here's my fire. I don't know. This looks like some kind of freaky Nazi symbol or something. I'm sorry. I don't know. This is almost the Iron Cross there. Okay? So, we've got the flame. Okay? Boom! Okay? Now, that flame is just to get these bonds to break. Even further, they release, once we break one, it's just like this crazy amplification happens, and that's why we get the boop, the pop. Okay? You could imagine that pop would be a little bit louder if we had more hydrogen. Let's do it. Okay? Well, once that pop happens, the oxygen molecule has now, so that was a molecule. How many molecules of oxygen do we have? One of those. Right? That's one molecule. Spell that right? That's one molecule. We add some energy to the system. Now what do we have in here, guys? How many particles do we have? 6. 6 what? They're all free. No, they're not molecules. We've broken bonds, dude. No electrons have been transferred. Atoms, good save. Okay? Okay? Now, keep in mind they're under high energy. I mean, we've got fire, and man, that reaction happened pretty quick. Okay? Sometimes that happens. Bonds break, new bonds form. It can happen pretty quick. Don't you want to wait a while? Right? Nobody? Come on. And they find each other, and true love happens. And our end result is what? What do we get at the end of the show? We started off with a total of 1, 2, 3 molecules. We broke those into 6 atoms. Those atoms reconfigured into a new substance. That's chemical change. New particle, new substance. Into what? To what? What? Ions? You're killing me here. Water. Which is what kind of particle? He knew that. Back out of there. He was just faking all out, seeing who's paying attention. Right? Yeah. So, form what? What do we get? Out the other end. Thank you. How many? How many did we get out the other end? Yeah, I'm not making you count past 3 today. Oh, sorry, 6. So, okay? Yeah, 2 water molecules. Okay? So if I could actually represent this reaction, which is what the flame test was that we did yesterday to verify that it was indeed hydrogen. Answer to the question, that's the other thing. Okay? We say hydrogen plus oxygen gives us water. H2 plus O2 gives us H2O. But now we can see that it's going to take 2 H2s to react with 1 O2, and we're going to get 2 waters out the other end. So 3 molecules had to go into the system, but we only got 2 out of the system. But the 2 that we got out are actually better for us, right? Because I'm going to suggest that we don't actually inhale hydrogen and then, you know, light a match in your mouth. That'd be bad. Okay? Yeah, right? Yeah, a little explosion in your mouth. Okay? Right? So that's where we get this idea of balanced chemical reactions. And then someone astutely caught, hey, wait, where did that particle, did we lose an atom somewhere? No, we didn't. But keep in mind, this reaction system, I mean, how many hydrogen atom molecules do you think we were pumping out there? Out of that system, right? That was coming off of the gas, right? Those gas bubbles. I mean, how many hydrogen molecules could fit in just one of those tiny little bubbles? Gazillions. Too many to count. So this would be happening on a grand scale. And what's really cool is you can actually calculate it. And you would know exactly how much hydrogen you need to put in your car if you had a hydrogen-powered car. And in fact, there is an engine called the fuel cell, the Ballard fuel cell, that does exist, that runs on hydrogen. The problem is hydrogen is an extremely dangerous gas, okay? Even more dangerous than gasoline. So that's how that works. So that's molecular bonding, right?